Hello friends, welcome to Ashok IT. In this video, we will be seeing Java OOPS concepts. What is class, what is object, and the four important OOPS principles, that is encapsulation, inheritance, polymorphism, and abstraction. We will also be seeing overloading and overriding. And other than this, we will also be seeing how to use and when to use this keyword, super keyword, and final keyword in a Java program. So we will be starting with the object-oriented programming. When we say OOP stands for Object-Oriented Programming. In case of procedural programming, we write procedures or methods which will perform operations on the data. But when it comes to object-oriented programming, it is about creating objects that contain both data and methods. So we can say in object-oriented programming, objects will combine the data and methods in a single unit. So we will be using the concept of classes for which we will be creating objects. So each and everything in Java is treated as objects. And object-oriented programming has several advantages over procedural programming. Object-oriented programming is faster and easier to execute. It provides a clear structure for the programs, and it also helps to keep the Java code dry. So here, meaning of dry is don't repeat yourself. So as we are not writing the code again and again, we are not repeating the code, it will be easy to be maintained, modified, and for debugging. And object-oriented programming will make it possible to create full reusable applications with less code and shorter development time. So development time will be reduced. Also, the applications will become reusable if we are using object-oriented programming. So now let's see the basics of object-oriented programming. The very basic and important concepts of object-oriented programming are class and object. So when we say class, it is a template for objects. When we create a class, it is like we are defining what a object should contain. So class is a template for objects, and an object is instance of a class. So object acts as reference of class, and class can also be defined as blueprint from which you can create an individual object. And class, when we declare or create a class, it does not consume any space. That means no memory is allocated to class when it is created, but when we create object for the class at that time, object will be given memory in the CPU of class type. So when it comes to object can be defined as instance of a class. And when the individual objects are created, they inherit all the variables and methods from the class. So whatever variables and methods are defined in a class, they are inherited by each and every object created for that particular class. And an object contains an address and takes up some space in the memory. So whenever we create a new object for a class, every time every new object will be getting a new memory in the CPU of class type. So now let's take a simple example here for class and object. Now here we are having a class car, and we have here the object created for this class car as Volvo, Audi, Toyota, Honda City, and Swift. Without seeing this part, that is without seeing this class, if we are just seeing these objects, Volvo, Audi, Toyota, this may or may not be name of a car. This can be name of a company, this can be name of person or anything. Just if you see only this part, you will not be able to say that it is a car. But when we are seeing the class, we can say all these five names belong to car. All these five names are the names of a car. So class is nothing but definition of object. What is an object is defined by the class. And here, what are these five names are defined by this class as car. So these 5 things are nothing but car. Similarly, when we just see these objects like Cello, Reynolds, Flair, and Parker, we will not be able to know that these are the names of pen. But when we see the class of it, class is defining it as a pen. So by seeing the definition of class, we are able to say that these objects are nothing but these are pens. So class defines the attributes, or we can say the features of object, and class defines the behavior of object. So the features and behavior of an object are defined by the class. Thus, we call class as a blueprint or template for objects. So in Java, to create a class or to declare a class, we use the syntax as follows. So here, class keyword followed by the class name, and we start a class with curly bracket, that is opening curly bracket. Inside the class, we will be having data members and related member functions. And we close the class or end the class with closing curly bracket. So here, according to this syntax, here we have an example of class where we have created a class student by using the class keyword. We are starting the student class here. The data member is nothing but the variables of class, variable declarations, or the data values used in the program. So here int type of ID we are declaring as the data member, and member function here is void display. So member function or we can say method is nothing but set of statements which when executed will perform some task. So here the function or member function is display, which when executed will display ID. So this is an example of class. Now next we will be seeing how to create object for a class. So syntax to create object for the created class is class name followed by the object name equal to symbol new keyword followed by the class name and parenthesis and semicolon. So using this syntax or using this format, we can create object. So in the previous screen, you have seen that we have created student class. So for student class, if we want to create object in this manner, we can create like student class name followed by the object name S1, which is user defined. We can, according to requirement, give the object name equal to new keyword followed by the class name and parenthesis semicolon. So this line is going to create object S1 for the class student. And for a single class, we can create n number of objects, and every object of a class will inherit the variables or methods defined in that particular class. Encapsulation. Encapsulation is combining or encapsulating data and function in a single unit. So the data members and member functions we will be combining as a single unit, and this is done using classes in Java. So as we have created a student class and we have placed ID and the function display, so class is used to combine data and function into a single unit or to achieve encapsulation in Java. And we use classes in Java in order to hide the data or functions within the class, that is from other classes. We will be hiding the data and functions, and we will be controlling the access to data and functions using access specifiers provided by Java. So the variables or data and the related methods or functions are encapsulated in a single unit called class. And by doing so, we are hiding the data and function from outside world. That is, for all the things which are outside of this class, this data and function are invisible unless and until permission is given to access it using access specifiers. So syntax for using encapsulation in Java is nothing but using of class. So class keyword followed by class name within the class data members and member functions, and data members and member functions access can be controlled using the access specifiers like private, public, protected. So when we declare something as private, the data member or function, it can be accessible or visible only within that particular class. We cannot access it outside of this class. So to see it practically, let's see the program in Eclipse. Here is the Eclipse IDE where I have already created a project in which I had placed a class called student.java, and there is also another class student1.java. Now in student.java, I have placed the function main, that is public static void main function, and within this student class, the data member I have taken is integer type of ID. So int ID here is the data member for this class student, and void display, which displays this ID, is the member function or method present within this class. So here the first line creates a package college. The class student belongs to the package college, which is started here with a opening curly bracket. Within the class, we are declaring here the data member as int type of ID. And then we are here defining a function display which prints ID on the output screen. So in the main, whatever statements are present, only those will get executed when we execute the program. So that's the reason to execute this display, we need to call it within the main. For that, first thing, to access these members of class from static context, we need to create object for the class student. So here we are creating obj object for the class student, and using this obj, we are accessing the data member ID, assigning to it 90 as value. And then with the same object, we are calling the function display, which will be displaying the ID as 90. So when we combine the data and function in a single unit called class, it is nothing but encapsulation, combining of data and function within the class. Now suppose I have taken in other class the same thing, but little differently. Like here in student 1 class, I have taken int marks. So in student, I have taken int id, here int marks, and here I have taken another function display marks, which will be displaying the marks. But here I made it private. The marks, I made it private by writing private before it, by declaring it private using the access specifier private. I made the marks private. Now let's try to call the display function and also access the marks of student 1. So I will be here creating student 1 object. So as obj1. So this line is creating object 1 for the second class student 1, where we have data member as marks. So marks here is the data member, which is declared as private. So I will be accessing using the obj1 object dot marks. I will try to access marks, but I'm in suggestions not getting. So if I write it also here, the marks, I will be getting error. The field student1 dot marks is not visible. So I'm unable to access it from main because it is declared as private. So in student 1, we are controlling the access, or we are hiding this marks by making it private. So when we write private, it is visible only within this class. It cannot be used outside of the class. That is in student, we cannot use it, not even in main function. So to assign value to this marks, we can use the function of this class, or we can make use of constructor, but we cannot access it directly from any other place which is outside of the student 1 class. This marks can be used only inside this class. So this is how we can control the access of data members. And also if we write here private before the function name, even this function will not be visible. So if I try to access the function previous it was giving you the suggestion of display marks. Like if I don't write private here with this object, I will be getting the suggestion display marks because I am able to access it or it is visible to the main function. But when I make it private, I will not be getting any suggestions because it is not visible as it is private. So by making it private, we can hide the data or function only within the class and without showing it to the other classes or outside of the class. So this way we can control access to data and also function by using classes in Java, which is nothing but encapsulation or hiding data or hiding implementation. In this video, we will be seeing inheritance in Java, which is one of the object-oriented programming concept. Inheritance in Java we mainly use for code reusability. And when we say inheritance, it is creating a new class by using features of existing class. So there will be a already existing class using which we will be creating a new class. So whatever present in the existing class can be used in the newly created class by using inheritance. And it can be also defined as deriving a child class by inheriting features of parent class. So here in the diagram you can see there is a class A and there is another class B beside which we have written extends A. So when we write extends A, B class becomes the child of A class. So A here will be called as superclass or parent class and B will be called as derived class or child class. So class B will have access to all the members of A except the private members. And the syntax for inheritance. So we will be having a class with the data members and member functions, and we may create a new class which extends the already existing class, and we can add additional members to this class, that is the members of this class, and this child class can make use of the members present in parent class. So the child class can access the members of parent class and also it can have its own members. So here is a simple example where we have a student class with a data member ID, where the ID data member or ID variable is declared of type integer. And then we are creating a new class student details, that is stu details, which extends student class. So now stu details class can make use of the data member present in the student class because stu details is child class. So here it is having a function or method display, a member function display, which prints ID. So it is not declaring ID in this class, but it is directly using ID from parent class and printing it on the screen. So to see it practically, we'll be seeing this example in Eclipse IDE. So here I have opened Eclipse IDE where I have a class student. So student.java file. So this is the class student within the package inheritance example. In the class, I have declared ID of type integer. ID is the data member of class student. And then I have taken another class stu details that extends student class. This stu details can have its own data members inside it. So this is data member of stu details or student details class. And we have also defined here a function display that prints. Display here is the member function or method we can say of class 2 details which displays ID and name. So name is the member of current class 2 details, whereas ID is the member of student class, which is the parent class. So as 2 details is child of student, it is able to access the ID present in student class. But if I remove this extends students, I will be getting here error. ID cannot be resolved to a variable. Create a local variable ID. So it has no access to ID when I remove extends student because it is no more a child of student. So if I write here extends student, it is able to access ID. Now in the main method, I am here creating object of child class. So here we are creating object of child class, and child class object is able to access the parent class member and assign value to it. Here able to access the child class member and also the child class. So These two members belong to stoDetails, and object of stoDetails able to access stoDetails members. But other than its own members, it is able to access the parent class member ID also here with its object. So using the object of child class, we are able to access parent class members and also its own members. And when I run this application, I will be getting ID and name displayed on the console or out. So this way we can make use of inheritance to reduce writing of code or for code reusability. So here already ID is declared, so we are directly using ID here and not redeclaring it. So this way we can use inheritance in Java to reuse the existing code or whatever declared in the parent class, all the declarations and the methods can be used by the child class without redefining or redeclaring it. In this video, we will be seeing polymorphism. So polymorphism is one of the object-oriented programming principle in Java. Polymorphism, when we say poly, the word poly refers to many and morphism refers to forms. So we can say polymorphism is existing in many forms, as poly refers to many and morphism refers to forms. Polymorphism in Java is divided or classified into two types as compile time or static polymorphism and runtime or dynamic polymorphism. Under compile time, we will be seeing what is overloading. So overloading comes under compile time or static polymorphism. Overriding comes under runtime or dynamic polymorphism. So under polymorphism concept, we will be seeing overloading and overriding. When we say method overloading is nothing but when the method with same name exists multiple times in same class but with different number and type of parameters. When the same name method or member function will exist multiple times with different types of parameters, then we call it method overloading. So here we can see a simple example. A student class is there which contains three print methods with different parameters. First method contains marks 1 and marks 2, which may be of numeric type, and the second contains ID and name, which is numeric and a text type, and the third print contains the grade, which is character type. So three different methods with same name containing three different type of parameters. So number and type of parameters we can see here are different, but the name of method is same. Syntax and example for the same here. So class followed by the class name, and within the class we will be having function A. Here we can see we have all the three times function A, but the parameters, that is number of parameters, is different and return type may also be different. So here we have taken an example class shape, inside which we have taken three methods: draw, draw and draw. So first draw method is containing two parameters, height and width, whereas the second method draw contains radius as parameter and the third contains side as parameter. So first method is drawing rectangle, second is used for drawing circle, and third is for drawing square. And the type of the parameters will be different. Similarly, the other type of polymorphism, that is runtime polymorphism, is method overriding. Method overriding comes under runtime or dynamic polymorphism. And in inheritance, that is when there is parent and child class, in inheritance, when child class redefines the method of parent class, it is called method overriding. So when we are using inheritance in Java, that is when we have parent class and child class in Java, then the child class will be overriding or redefining the method of parent class. So that concept is known as overriding or method overriding. And here both the parent and child class will be containing same number of parameters in the method. There is a parent class shape with the method draw. The same draw method with same number of parameters and return type will be used for drawing circle ones, rectangle ones, or square ones. So here circle is a child class, rectangle is a child class, square is a child class, whereas shape is the parent class. So different child classes may use the same method of parent class in three different ways here. So that is method overriding in Java. So let's see it practically in IDE, that is Eclipse IDE. Here we have a student class in the package oop.example. So within the student class, I have here taken three methods add marks. All the three methods have same name add marks, and the first method contains two parameters of type integer. The second method has a single parameter of type integer, and the third method has three parameters of type float. And we are using the first method to add two integers, and we are printing the same. In the second method, we are adding integer to 500. That is, whatever integer we are passing to this method, to that we are adding 500 and printing on the screen. And in the third method, we are adding three floating point numbers and printing the result. So to call all the three functions in main method, we will be creating the object of class first, that is student class object we will be creating. Using the object, I am calling add marks, but add marks here for the first time I am passing two integer values, which will call the first method which contains two integers. Then second time add marks I am passing a single integer which will match the parameter and call the relevant or suitable function. So here there is only single integer parameter, so this method will be called second time. And third time I am passing three floating point numbers, so this will be calling the third function which has three float parameters. So when I run this, so upon running this, the first adding two integers 75 plus 85 160 we will be getting as the addition result. The first add marks function will print 160. The second add marks function will be printing 500 plus 98, that is 598. So 98 we have passed in the main method, which is added to 500 in the add marks function method. So we will be getting 500 plus 98. And in the third time, adding three floats. So all the three floats are added and we got the 259.57 etc. value by adding these three floating point numbers. So this is method overloading in Java. And in case of method overriding, we use inheritance. That is, here is the student class that contains these three methods. And I'm taking here another class 2 details, that is student details, that extends student class. So here's two details class extends students, and stu details is child class and student acts as parent class. So whatever present in student can be accessed by stu details. Now the first add marks method of student class, the first add marks method of student class of class student add marks method with two integer parameters is redefined by the stu details class. So here the add marks with two integer parameters is given a new definition by the child class. Here it is not only adding the two integers, but it is adding the two integers to 1000. So this way, when it adds two integers to 1000, it will be giving you plus 1000 as the result. Now, when we call using the stu details object, all these three functions or methods, so when I call all these member functions or methods with stu details object. So I have changed here the class name in main method. So this obj acts as object for stu details now. So now we are using the object of stu details, that is child class, and calling all the three methods. So when I call like this, here I will be getting 1160. That is two integers are added to 1000. That is 75 plus 85 are added to 1000. This is because of the new definition of add marks method. So when we are calling it with the parent class object, it will be calling the parent method. But when we are calling with child class object, as the child is redefining or overriding the parent class method, the new definition will be implemented. So This is overriding or redefining of parent class method. This way we can use method overloading and overriding in Java as compile time and runtime polymorphism. In case of method overloading, we are using the same name function multiple times in same class with different number and type of parameters, whereas in case of method overriding, the parent class method is redefined in the child class method, but the number of parameters and type of parameters will be exactly same as in parent. Only the change is in the definition of method. In this video, we will be seeing abstraction in Java. So abstraction is one of the object-oriented programming concepts, and abstraction is achieved in Java using abstract classes and interfaces. So abstraction is hiding the functionality or implementation and showing only necessary details. So in case of abstraction, we will be showing only abstract data or the necessary details, and functionality is given by child classes of the abstract. So we will be using abstract classes or interfaces to achieve abstraction in Java. So here in the graphical example here, employee contains display details as the method with no definition, and the child classes of these employee details, employee class, that is teacher, accountant, and principal, three different child classes, can define the abstract method display details in their own way. They can override the abstract method or give definition to the abstract method according to the requirement. So abstraction is showing only necessary details and hiding the functionality or implementation of the method. So when we use abstract class is a class that contains at least one abstract method. So abstract method is a method without definition or body. So the class that contains at least one abstract method is abstract class, and abstract class can contain abstract and also non-abstract, that is method with the definition and method without definition, both can be present in the abstract class. Abstract class and method must be declared as abstract using abstract key, and abstract classes cannot be instantiated, that is we cannot create objects for abstract classes. We can access the abstract class members only by the child classes. So only child classes of abstract class can implement the abstract functions. So here is a simple example or syntax. So abstract keyword followed by the class name, and abstract class contains non-abstract methods and also abstract methods. So here is a simple example in Java. Abstract keyword followed by class keyword followed by the class name student. It contains a method void test which has no definition. It has no, it is not defined, and it is also declared as abstract because it is an abstract method. And the other method display name is containing here the definition. So it is a non-abstract method, and the abstract method in abstract class can only be defined by its child class. So there is a class 2 details that extends student and implements the method void test, that is abstract method is implemented here in the child class. And in the main method, we can create object only for the child class but not the abstract class. And using the child class object, we can access the method present in abstract class and also the methods present in child class. We can also use interfaces to achieve abstraction in Java. So interfaces are pure abstract classes that contains only abstract methods. The interface cannot contain non-abstract methods. So only the classes that implement interface must provide functionality to the abstract methods of interface. So abstract method is a method without definition, and non-abstract method, when we say, it is a method with definition. But interfaces can contain only abstract methods. They cannot contain non-abstract methods. That's the reason interfaces are pure abstract classes. When we use interface in Java, it can contain only a abstract method which is by default declared as abstract and public. So we need not declare it abstract or public. It is by default public and abstract. and the class that implements the interface can only give definition or can only implement the abstract method present in the interface. So here there is a interface pet that contains abstract method test, which is implemented by the class dog that implements pet interface. And here the dog class implements or provides definition to the abstract method of interface test. Here the abstract method test is implemented and there it prints interface method implemented on the screen when it gets executed. So we create object for the interface which is of type dog, or we can also directly create the object of dog and call the method present in class. So to see it practically, we will be seeing the example in Eclipse ID. See it practically, we will be seeing in Eclipse ID. Here in Eclipse ID, I have created a class student that is declared as abstract, and this student class contains a non-abstract method and also a abstract method which is named as addMarks and contains two parameters of type integer. So, and here it is not having any definition, that is it is abstract method. So we should declare the abstract method as abstract and also the class addAbstract which contains at least one abstract method. So the class that contains at least one abstract method must be declared as abstract and it cannot be instantiated. That means we cannot create object for student, and only the class which is child of this class, that is only the child class of student. Here studetails class I have taken which is made as child of student. So only the child class can implement the student class abstract method. So this abstract method addMarks is implemented by studetails, and here we are implementing it as it prints two integers by adding it to 1000 and prints the result. Here addMarks is implemented by studetails which is child class of student, whereas student here is abstract class which contains abstract method addMarks, and we can create in the main method the object of studetails, and using the same object we can call the addMarks function or method. So when I run this, I will get adding two integers 2000. So the two integers which we have passed are 75, 85, which are added to 1000 and the result is printed. So abstract method is nothing but a method without definition. Abstract class contains at least one abstract method. And if you try to create object for student, like if I create student class object, we will be getting, so here I tried to create object for the student class, which creates an error, cannot instantiate the type student. So because student is the abstract class, we cannot instantiate it or create object for it. So whatever members present in student must also be accessed with object of its child class. So even the display function method which is present in student class is accessed using its child class. So welcome is printed by student class non-abstract method which is called by the object of its child class. So this was abstraction using abstract classes. Now let's see a interface. So I have here created an interface. So interface is nothing but a pure abstract class which is created using interface keyword followed by the interface name. So here I2 is the interface name that contains a single abstract method addMarks. So here we are not declaring public or abstract because by default the methods present in interface are public and abstract. So this method, this abstract method of interface can be implemented only by its child class, which is implementing the interface. So here we have taken another studetails2 class that implements interface. So whenever we take interfaces in Java, interfaces are implemented by their child classes, whereas classes are extended by their child classes. So when we use classes, the child class extends the parent class, whereas when we use interface, the child class implements the interface. So here, the child class is providing implementation or definition to the abstract method of interface. And here we need to declare it public, because by default, the interface methods are public. We need to declare it manually public. And if we don't declare it, we will be getting an error, cannot reduce the visibility of inherited method. Same way, we can create object for the toDetails2 class. And because interface does not contain any other method, we are removing this. And I am here changing the value. So when I run toDetails2 prints, adding two integers 2078 plus 95, and we get this result. So this way, we can achieve abstraction using the abstract class and also interface in Java. So interface can contain only abstract method, whereas abstract class can contain both abstract method and non-abstract method. So the main differences between abstract class and interface is abstract class can have abstract and non-abstract methods, whereas interface can have only abstract methods. Whereas since Java 8, there is a default keyword using which we can provide some static methods in interface. So we will be using default keyword to provide method a definition within the interface since Java 8. So abstract class does not support multiple interface, whereas multiple inheritance, whereas multiple inheritance in Java is supported using interfaces. Abstract class can have final, non-final, static, and non-static variables, whereas interface has only static and final variables. Abstract class can provide implementation of interface, and interface can't provide the implementation of abstract class. The abstract keyword is used to declare abstract, whereas the interface keyword used to declare an interface. So abstract class, whenever we use abstract class, we declare it as abstract. And whenever we create an interface keyword is used to create an interface. So we use interface keyword followed by interface name. An abstract class can extend another Java class and implement multiple interfaces also. An interface can extend another Java interface only. So an abstract class can be extended using keyword extends. So in case of abstract class, when we create a child class for an abstract class, we use extends keyword, extends abstract class name. Whereas to inherit this interface, we use implements keyword, implements followed by interface name. Java abstract class can have class members like private, protected, etc. Whereas members of Java interface are public by default. All the members in interface are by default public. So here is the simple syntax: public abstract class, class name, which contains an abstract method. Here public interface, interface name, which contains an abstract method. So this is how we can use abstract class and interface in case of abstraction or to achieve abstraction in Java. In this video, we will be seeing very important keywords, this, super, and final in Java. So how to use this keyword, super keyword, and final keyword, and when to use these keywords, we will be seeing practically and theoretically in this video. So this keyword in Java acts as current class object. Super keyword is used in child class to refer to parent class members. And final keyword, when we use in Java, if anything is declared as final, like variable, class, or method, then it cannot be modified. Its definition or value will be fixed. So when we declare a variable, class, or method as final, it cannot be modified. And this keyword mainly used to refer to class members when the instance and local variable names are same. And we cannot use it in static context. Super keyword is used when parent class function definition is required in child class. Or to refer to parent class members, we can use the super keyword. To refer to parent in the child class, we can use super keyword. And then final keyword is used with variable method and class to make its definition or value fixed. So here is simple example of this keyword. So to use this keyword, the syntax is this keyword dot variable name or dot function name. So this here acts as current class object. Without creating object, we can directly use this keyword in the current class to refer to the class name. And the members of class can be accessed using this keyword. It can be variable or a function. So here is a class student which contains a data member ID which has the value 1, 2, 3, 4. And there is a member function or method in the class student that also contains a ID variable with 90 as value. So here within the method, the ID variable is local, whereas the ID variable which is directly within the class is called instance variable. So when the instance variable name is same as the local variable name, and in this method display, we want both the variables. We want to use both the variables ID. So if we use ID both the times, we will be getting 90 both the times as value. But if you want to access this ID from this method, then you can use this keyword dot ID, that is the class member of ID will be referred. So this acts as current class object, that is student class object when used with the class members. So it will be getting you here the class member instead of the local member. Similarly, super keyword is used in the child classes to refer to parent class. So super refers to parent class. We also called parent class as super class. So super keyword when we write within the child class, it refers to the parent class member. So here we have an example student class with the data member ID and a method display that displays the ID. And then we have studetails class that extends student class. So studetails here is the child class of student class, which is redefining the display method of student. And in the same method, it is also invoking or calling the display method of student by use of super keyword. The super dot display when we write here, it refers to the display method of parent class. And then the third keyword final. When we use final keyword, we can use final keyword in with class, with variable, or with function or method. So with the member function or method, with the variable or with the class name, we can use the final keyword. So whenever a class is declared as final, it cannot be inherited. Whenever data member is declared as final, it cannot be modified. And whenever we declare a method as final, it cannot be overridden. So the data member cannot be modified, the class cannot be inherited, and the method cannot be overridden if it is declared final. So to see it practically, we will be using Eclipse IDE to practically do the program. Here in the Eclipse IDE, I have taken a class student that contains a method display that displays welcome. And I have taken another class studetails that extends student. So this class is studetails is child of student class. Student is the parent of studetails class. Now within this studetails class, I have taken a data member num1 with value 100, and within the method add marks, I have taken a data member num1 with value 200. So this will be the local variable which is local to the method. Only within the method it can be used, whereas the num1 which is directly inside the class is instance variable which can be used by all the methods present in class. So if you want to use both instance and local variable within this method add marks, so if we display num1 both the times, we will be getting 200 as the value. But if we write this dot num1, it will get you the instance variable. So this will print when we write this dot num, when we print this dot num1, it prints 100. And when we print num1, it prints 200. And we have here used super keyword. So super keyword as studetails is child of student, and student contains a method display that prints welcome, and we want this method to be called in child class. So to call it, we can use super.display to call the parent class method. So, or to refer to parent class, we can use here super.display. So when we say this, it refers to display is parent class method or super class method. So this way we can use this keyword and the super keyword. So in main, if we want to call the method present in stoDetails add marks, we need to create object for stoDetails, and using that we will be calling this marks. When we run, we get from stoDetails to adding two integers 1173. And if we call this, so here we have created object for stoDetails to not stoDetails. So I'm making it stoDetails. So stoDetails object I have created, and with this object I have called add marks, and when I run this I get welcome message which is by super.display, and we get stoDetails adding two integers method. So this message is coming from stoDetails method add marks. So this gives you stoDetails adding two integers to 1000, and then we get the num1 value, both the num1 values, that is 200 and 100. If I give proper spacing, 200 and 100. So this is local num1, this is instance num1. Now similarly, I am taking another class test where I am declaring a data member marks of type integer with 90 as value. I'm taking a method display where I am modifying the marks value and printing the same, and also printing a message goodbye. So now if I want to call the display, I need to create object for test in main method. So here test object I will be creating as O, and using O I'll be calling the display function. So when I call display, I get marks 100 and goodbye message. Now if I declare this data member as final, I get error here that final field cannot be assigned any value. So we cannot modify the final variable. This gives error or creates error because we have declared the data member as final. So whichever variable is declared final, it cannot be modified. So it creates error because final variable cannot be modified. Then if I try to inherit this class, like if I create here another class in same file, like test2, and if I write here final, and if I try to extends test, it gives me error type test2 cannot subclass the final class test. And if I remove this modifier, that is final keyword, it will allow me to inherit. That is, we can extend test. We can create test2 by extending test if it is not final. But if I make it final, it will not be allowing us to inherit it or extend it. So we can say final class cannot be inherited. So this creates error because final class cannot be inherited. So I'm commenting this, and same way, if I remove this, it allows inheritance, and this function, this method, if I override here in the child class, that is, if I just display the message goodbye, I want to just display goodbye, not other things. So here I'm changing the definition of parent class method. That is, we are using here method overriding. We are overriding the display method. So child class test2 is redefining the parent class display in it. So this is method overriding. And declare final, when I declare this method as final, it gives me error because the final methods cannot be overridden. So method overriding is not allowed for final method. So, and also For final class, extending is not allowed. That is, inheritance is not allowed. Final class cannot be inherited. Final variable cannot be modified. Final method cannot be overridden. So whenever we declare variable, class, or method as final, its definition or value will be fixed and cannot be modified by user again. So that is final keyword. Super keyword for referring to the parent class. This keyword acts as current class object to access the class members. Final, this, and super keyword are used in Java for final for making the fixed definition of fixed value. When you want to use a fixed definition of fixed value, we use final keyword. Super keyword when you want to refer to parent class, and this keyword acts as current class object to access the parent class members or refer to parent class members. We use this keyword. So thank you for watching the video. Please like, comment, and subscribe the channel for more updates on Java.